I would be happy to stay.
Yeah, and you can do that too. If you want to stand, that's just fine. Okay, well then we'll move on. You guys can just stand in a row. Okay. So thank you very much, everyone, for being with us today. Those of you who know me, I am Merle Massey. I am the coordinator of undergraduate research. Yes, you guys got to come right in front of me. I am not going to this. And I reached out to faculty who this past year have had an undergraduate student working for them in their research group, in their research lab. And it was really easy process. Everybody who put an undergraduate student in the summer symposium, that's who I reached out to. And it was quite funny because I had about 12 people, faculty says, absolutely, I'll do that. And then I had to coordinate schedules and come up with a time that worked for me. So that was the most interesting part of this. However, I'm really, really grateful for who have come. And for those of you who don't know, I'm going to start, and I'm just watching this up. Michelle Collins, Katelyn Halpape, Sean Prager, Arinjay Banerjee. And what I'm going to do first is that I'm going to ask them to go, we'll start with Arinjay and go across, say who you are, what where you're situated at the University of Saskatchewan. And then once we've done that round of introductions, we will jump into some questions. I'm going to go and sit elsewhere. I won't be standing behind you through this whole thing. And after we've gone through a bit of a roundtable, we'll talk about a few things around undergraduate research. We will open it up to questions, both here from the floor, as well as questions online. I'll come back and moderate that. So if everybody's good to go, this is what we're going to do. So Arinjay, if you could start us off.
Okay. Oh, there you go.
There you go.
Good. Hey, I'm Arinjay Banerjee. I'm at the Vaccine and Infectious Disease Organization at VIDO. I'm appointed as faculty at the Vet College, College of Veterinary Medicine. I'm also cross-appointed as faculty at the University of Waterloo, UBC. So what we do in our lab, we study viruses. I'm a virologist by training. We also develop vaccines because we're at the Vaccine Institute. And one of my major goals is to facilitate training students across different institutions. So my students would go to UT or Waterloo or UBC, they bring students from other universities to VIDO as well. So I'm really focused in this knowledge exchange and capacity building for infectious disease across Canada. And that's what we do.
So I'm Sean Prager. I am situated in the Department of Plant Sciences, which is the College of Agriculture. I'm also faculty in biology. So it's because I'm an entomologist, so I work on insects primarily, both in the context of things that kill plants that we don't like, and also, more importantly, as the things that transmit viruses and other diseases, especially in plants that people don't like.
Okay. Hi, everyone. I'm Katelyn Halpape. I'm an assistant professor in the College of Pharmacy and Nutrition. By training, I'm a clinical psychiatric pharmacist. So I practice at the Dubé Center, providing inpatient pharmacy consult services there. And a lot of my research focuses on quality improvement in that area. And I like to bring students on to help with different projects and help them to learn not only about clinical care in that area, but also how to advance both pharmacy practice and inpatient psychiatric care that way. I have a cross appointment with the Department of Medicine to work with the psychiatric residents there. And then within the College of Pharmacy, I do some work specifically in chronic pain and help manage interdisciplinary chronic pain clinic and do research around that area.
Hi everyone, my name is Michelle Collins. I'm an assistant professor in the Department of Anatomy, Physiology, and Pharmacology. I started my lab in January 2021, so we're a rather new group. Our lab is interested in understanding the genetics that underlie cardiac development and cardiac function. And so we do a lot of disease modeling using our favorite model organism, zebrafish. We do some cell culture work and some other sort of techniques in the lab. And I got my first taste of research when I was in high school and into undergrad. And so I'm really passionate about getting undergrads into my lab getting them to actually, do things and get their hands in there and learn whether it's something they're actually interested in. So, yeah, I'm happy to be here and answer any questions you guys have about this.
Awesome. So actually, I'm going to go right back to you with the first question, which you've started to answer, but I want you to draw it out a little bit more. So why do you like having undergraduate students in your research group? What do they bring that's different?
Yeah, I think undergrads come with this excitement. It's probably one of the first times, or first couple of times that you're in the lab that's not an academic lab, like one of your chemistry or biology labs. And it's neat because in an actual lab, you don't know what the outcome of your experiments can be. Everything is exciting and new. It's the first time you're looking at it. And so I think the energy that undergrads bring and the new set of eyes is really exciting to work with. And it's a good opportunity to get in.
Katelyn, can you add to that?
Yeah,
Same question.
I agree completely with that. And I think I often learn so much from my students too, from their questions. And I really feed off the energy they bring to my team. So I think, like Michelle said, and the fact that I learn while they're learning too. So I think it just pushes me to.
Sean.
I mean, I think all of the above. The other thing that we like is that there are research tasks that are not so exciting after time. it's to be honest, right? And so when you're a graduate student or beyond that, sometimes you don't want to do it. But undergrads, it's all new. So things that are not so fun when you're done a lot are still fun. And it's nice having undergrads because you have someone who's excited to do something new as opposed to the drudgery of doing the same thing you've now done for like 3.5 years. And that's really nice to have someone that's excited about doing learning new things.
Yeah, I agree, ditto. But I think the energy of the drive, not just for myself, for lab too. We try to be as equitable as we can when we recruit undergrad students. So today we interviewed 4 people, and I didn't interview, the lab did. I was a bystander sitting and watching. It was good to see how the lab got excited in the process of interviewing students, how my students appreciated that not one person was marking them. So we are learning, we're fairly new as well. And we are trying to be as equitable as we can in how we recruit students and how we create a safe space for great science. The other thing that I just thought about building on this. The other reason, at least for me, that it's nice to have undergraduates come to the lab is that we're trying to teach many things on many levels. So we're trying to teach some people how to become faculty members, some people how to run labs, and also people how to be teachers. And so undergraduates also represent, and this is not necessarily why I benefit you, but why I benefit other people, an opportunity for the other students in the lab, the other postdocs, the other people who work with, to practice their teaching and instruction to teach you how to do things. And there's no better way for them to learn to do that than to have to work with someone who doesn't know how to do things.
So there's a teaching and mentoring component to that. Then.
The whole process, right? At all of the levels.
So with that, and Arinjay, I'm going to start with you. What's your preferred way that students should approach you? What's worked? What hasn't worked? What have you seen students try and do? Do you have any recommendations or best ways to approach a faculty?
Anything works really. I can only speak for my generation. My PhD student in the lab, she approached me on social media, and we connected. And she's doing her PhD. She's from Scotland. So I think I'm not on TikTok, so don't. I mean, you won't find it. But dancing away from the lab is also okay. But for me, the biggest drive, we're driven. We can teach all the things. You come with the drive. That's all we need.
Sean, how about you?
I mean, yes. If you approach me one way or another, we'll figure something out. But that said, it depends on where you're coming. So this is where each of us is going to have a little different depending on what we do. I mean, all of us are probably say we're open to finding a way to find it. If you're coming to do your honors or your 4th year projects, that's different, for instance, than if you're coming because you just randomly want to work for us, because sometimes we just need people to help us and we hire them, which is different than the people who tend to be the ones who stick around in our group, which are the students who like bugs. Right? We have a very particular thing. Not many people like bugs. So usually we attract, because if you actually like insects, then you tend to find your way to us, and we usually lock on and don't let go.
I know that we had, I had a conversation, so we had a student panel a couple of weeks ago. One of the students who worked in your lab told us that you actually approached him. So is that something that was that normal, or was that a one-off?
No, well, it's sort of the reverse of the same thing. So different, okay. Some of us are in more privileged places to attract and identify students. Because I exist in 2 departments that have undergraduate students, because I'm an advisor to 2 different majors, and because I teach courses that have undergraduates in them, including a second-year course, I tend to know who everybody is at some point. So if someone sticks out as being particularly interested or curious, and I don't necessarily mean their marks, just if you ask a lot of questions, it seems like you get a little more excited than ever. Usually those are the people that we're going to try to find, because I want people who want to work on viruses or bacteria or insects, because they're small, particularly if they don't want to. So yeah, when someone stands out, we tend to try to.
Fair.
Yeah, and I would say I agree with that piece as well. I get a lot of my students from teaching them, and we meet each other that way as our first encounter. And I have only been here for a couple of years as well, so it's still pretty new, but the students I've hired are students that stood out in class that later came to ask me questions, and we connected that way. And I think that's probably a pretty common occurrence in terms of people crossing paths. So I think being authentically interested in the topic and showing that we do pay attention to see that.
Yeah, so I don't actually teach that much in the, at least the second-year level. I have some hours in 4th-year classes, so I don't really get a chance to connect with many students that are looking for research. So I try to go to things like research nights or things like that, where I might get a chance to show what we do and connect with the students that could be interested in our research program. So I recognize a few of you guys from other events too, so that's neat to see. I would say in terms of getting in contact with people, just send an email. That's how most of the students that have come to my lab have met me. So they send an email, they tell me what their interests are, why they're interested in joining our lab, and then we go from there and have some conversation about what their goals are, how they see themselves, fitting into the lab. And so definitely feel free to reach out by email to people too, in addition to things like Twitter or whatever. So have as
One of the most common questions that I get in my role that students worry about the most is their marks. And from my understanding from faculty is that some faculty do hold those marks in very high regard and they watch that, others don't. Could the 4 of you maybe talk about that? And Michelle, if you could start.
Yeah, sure. So I wasn't a great student in undergrad. I will be completely honest. I didn't really connect with a lot of the classes that I took until I was in my 3rd year and 4th year. And so I really struggled academically, I think. And I also felt the same way, like, am I going to get into a lab if I've got like a 72 in organic chemistry? I don't know. So for me, I don't put a huge weight on grades. Grades count a little bit if we're thinking about applying for some of the summer project awards, because you need to have higher grades for some of those. But for me, the key is motivation. If you come with, I'm interested in this because of a particular reason or something like that, that resonates more with me than having a 95% coverage.
Yeah, and for the most part, I agree 100%. I think sometimes we do need to look at marks when it comes to certain awards and that sort of thing. But in terms of the nitty-gritty of doing projects, I think if the person has drive, motivation, interest, that goes a long way. And a lot of the skills in terms of research can be taught, and if the person has that internal motivation to do it. I think that's one of the most.
Yeah, I largely know. But again, what everyone said, it matters for certain things. I'm not that interested if you're going to come and do a good job. The exception in my case would probably be if you didn't do very well in the courses I teach, I would maybe be a little concerned. At least we'd have to go talk, because I would wonder whether or not that meant you weren't going to have the preparation to do some of the things that we do. But outside of that, I'm not concerned. I don't necessarily know that. Unless you have poor marks. I don't necessarily know they're always going to reflect how well you go and sort of unleash you on the lab.
Yeah, same. But I think for me, if you're sending me an email, perhaps take the time to address us properly. Don't call them James and me. Don't call me a nutritionist when I'm not. So if you don't have the time to write the proper email, trust me, I certainly don't have time for the response. I won't. That's my first short listing. If I see it's a generic email, I just delete, I don't respond. Then I see if it's got a name, great. But then you've got my expertise wrong, delete. I just can't respond. I get over 100 emails from students. I just can't respond to all of them. But if you've taken the time to read what we do, and you come up with an idea that, hey, this is what I think I'd like to do. That's my first point of, yes, I'm going to respond to this. Because the student is thinking about what they'd like to do. It's not generic. That's just how we do it, because large people does time. Just can't respond to all of them.
Yeah, and I was just going to add to that. I think especially in a professional college that I'm looking for someone that is going to work with me as a professional. So I think a well-drafted email, all of your communication with me should be professional. That's something that I'm definitely looking for. And in some ways that goes above marks in certain respects.
And I think it also adds to this, that you paid attention to the details. And then that translates to your ability to work in the lab. Because a lot of what we do, you have to pay attention to details. And so, things like drafting a well-written email or paying attention to the requirements for the application are really important. And I think can also translate into abilities in the lab.
You raise an interesting point, and it's one. So we did a session in September about how to approach a professor for a research position, and we had a mini student panel as part of that as well to talk about how they approached professors and what worked for them. But your point about being professional in that email, making sure that you're not sending around an email blast to 15 professors. You need to make sure that it's targeted, that you've paid attention. These are all things that we cover. So if you haven't watched that video, go watch it. I promise you, there's good things in it. But it does raise an interesting question, which is where we're going to go next. Students, in addition to marks, the next question that students ask me probably more than any other is, what are the skills that I need to already have? I'm only I just finished my first year, just finished my second year. Even some were worried, I just finished my third year, I don't know enough yet. Why would they even talk to me? There's just such fear. What would you say to a student? And Arinjay, we'll start with you.
So I started my lab last year. I had to deal with students that had no lab experience before COVID, but there were shutdowns, and we didn't penalize them for it. There were students that just couldn't enter research labs. And trust me, we had 2 students that had no experience. They were fantastic. They performed at the level of grad students, if not senior grad students. So I don't know. I don't think not having a research background is not a no for me. For me, it's the drive. Are you critically think to an experiment? So we interview you. The lab does. We give you a question, and then you go on the whiteboard and you explain this. Like, this is gene X. What would you do with it? Anything, take it to space if you want. But we want to see how you critically think through that process. That's how we recruit students in our lab.
Sean.
It's our job. Full stop. It's our job to teach this. And at least in my lab, we do an enormous sort of spectrum of things. So sometimes we adjust. So sometimes you come in thinking you're going to want to do molecular biology, and it turns out you're not very good at pipetting, so teach you to count bugs instead, and that works. But it's our job to teach you to do. That's the number one reason to do undergraduate research. No, it's the number 2 reason. The number 2 reason is so we can teach you some skills. There's a whole bunch of other reasons that are probably.
Yeah, and I think in addition to all that, what we were talking about before, professionalism and other transferable skills like good communication skills, being conscientious, hardworking, having an open mind, wanting to learn. I think those are things that cross, and you could work with any of us, and we could teach you what we do. But yeah, that's our job to teach you that.
And I think when you send your applications and you send your resume, all of the extracurriculars that you do tell us the story about who you are as a person. So if you had part-time jobs, like whether it was at McDonald's or something else that would be more relevant to your field, it doesn't matter. If you did sports, any of these kinds of things speak to your ability to manage your time. And that's a really important skill that I look for.
I work weekend graveyards at a gas station, save money to buy a car, and there's no cheap that. And that taught me a lot of life lessons that graduate school taught me in Australia to Canada, India. None of that taught me that job taught me. So have that when you see people that you've had life experience.
So communications, professionalism, these are some of the core skills. Do any of you have colleagues who are non-scientific colleagues that who have supervised undergraduate students? There might be some students here who are not scientists. What advice might you have for them in terms of what you've maybe heard from some of your colleagues? Yeah, like I'm a historian, for example. I would.
That's how I look.
I'm a humanist. And no, I'm just wondering. I always love it when someone engages with me, especially when they're sports scientists. They're like, really, Merle, you want us to talk about doing research in a non-science field? I'm just saying there could be someone in the audience.
I could give an example of perhaps how things have gone. So we've had students that have gone to medicine, students that have research, and my most recent student asked her, she won Survivor Series last week. So she won the TV show. She's a celebrity. So whatever you want.
I think everything we talk about applies probably whatever the discipline is.
Yeah.
And I think connecting with whomever you're seeking out to do research with, to understand maybe there are some parallels or things they're doing that you're interested in. And I think really exploring in yourself why you want to do the research. If you don't have a clear picture in yourself about that, then it might not be for you, because you have to have like a reason within yourself to show up and ask for the stuff.
And it might be like that you find a course that you really liked, or even a lecture within that course that you really liked, and you kind of latch onto that as a theme that you want to explore. Because I know in undergrad, the research that I did, it's not like I was like, oh, I really want to learn how the eyeball works, but that's what my lab was doing, right? But I was interested in learning, molecular biology techniques. I was interested in working with animal models. And so you might not have a very fully fleshed out idea of what you want to do, but at least try to think of the classes that you really liked or connected with, and try to find those themes in the lab that you're trying to get into.
Yeah, absolutely.
So you've got great resources on campus for advice and for your concept. But if you could reach out to faculty and stuff, a lot of us have gone through this stage. Believe it or not, we were undergrad students. So come and we may identify with this. We have friends who identify with it. So use us. Come send us an email like, I need some advice. How do I do this? Or am I doing the right thing? We may not have the right advice, but we can direct you to our colleagues who may have similar advice.
What do you do as faculty members when you have so many great applicants, but you only have space for 1 or 2 students? What do you do in those situations?
This is really hard. I don't have a good answer for this, to be honest, because I would say that 80% of the people that apply would be fantastic fits for the lab, because they come motivated and they're excited. And this is a really hard thing to kind of distinguish yourself from a cohort of really excellent students. So at that point, talking to students in the lab, so having the lab also be part of the decision-making process is important, especially because a lot of the undergrads that come in will be paired up with graduate students. So then their input maybe is what helps to sort of facilitate that.
Yeah, and I can't speak to this. I haven't encountered myself in this situation. Someone has.
Again, it depends. I'm not sure that scenario is a great one, but we tend to find people for some things. But again, it also depends on the context of what you're coming to look to do research. And so within the College of Agriculture, at least within the plant science, and biology, if you're an honors student, right, you need to go to a project. So there's a difference between students who are coming to find a project, they need to do something, and you're like the least terrible option. Or like the least scary faculty member they can talk to or something. Versus those who are like, who are really particularly interested in something and coming, versus those who just want to try to get involved. And I think we treat them differently.
you can always tell who's coming in to do the science, who's coming in to get paid. I mean, I can tell. But you talk to them and our lab interviews, like I said, I don't alone by myself ever. And it's the lab's decision, like you said, because students, undergraduate students who get prepared, postdocs or senior grad students, I won't have all the time to teach you how to write that, but I will have the time to mentor you for experiments and have to think with your question brain, help you with your scholarships. The other thing I also do is like today we have this problem of having too many good students. We can't place them all because funding is a big thing for us. And we'll take in as many students as the funding will allow. But the other students, I'm going to give them the opportunity to get placed in my colleagues' labs because I've already vetted them and we trust each other. If they have the funding, they'll have that. So we try and work both ways. You get a great student, the student gets a good lab. So that's we do.
Good to know that Vito, has that kind of breadth, which is great. And I know that Ag Bio has that as well. So
we do. We're so far off campus, but please come in. You're not, you're allowed to come in. You have to be escorted here, so but you're allowed to come in and meet us. Just ask questions. Just pre-arrange it. If you come at the door, the door's always locked.
We're planning a shore tour in the winter term. So excellent. Exactly. So that's a hope.
And the CLS too, which the other place that you don't necessarily always think is there, but it's also there. And there's cool stuff at CLS and there are cool people at CLS.
The Canadian Light Source, if you don't know what CLS is.
Sorry, the Light Source at the synchrotron.
And we were there 2 weeks ago with the SURE program. Yeah, we took 14 students. We were kind of over capacity, but we went anyway. And they did a great job. We had a wonderful time. It does raise sort of the next question that I'm curious about, and then I'm going to open it up so you guys can ask. What's your favorite story of something that an undergraduate student learned or did or happened in your lab? It can be funny, it can be scary, it can be, a eureka moment. And oh, Sean, you're going first.
So this wasn't here. This was actually before I moved here. So we're entomologists, which means one way or another we will among us. And if you work on bees in California, there's an extra layer of concern that you don't have here, which is that you can have African bees. So we sent this poor undergrad who is now a professor at University of Florida. So I guess it all worked out for him in the end, just clear. But when he was in his last year, his fourth year undergraduate student, we asked him to go out and collect some bees and bring them back to the lab. He'd done this many, many times. Got in the truck and he drove out to where the beehives were, the apiary, the beehive place. And the bees were very angry. He did not know that, and they chased him back to a pickup truck, and he had a hightail of bees chasing him all the way back to like halfway, probably down the driveway back to sort of the main road. So I mean, it's pretty hard to beat that story. He's very upset, sort of very confused at why they were upset. They weren't Africanized, but we were afraid they might have been because we hadn't checked on them in a while.
They were having a really bad day.
He had a bad day, but yeah, but he actually was an entomology major. He went to graduate. He finished his project in our lab. He did his graduate work, and now he's faculty in Florida. So
still studying bees?
Not studying. Yeah, actually, yes, still studying bees with drones. So he now has drones to follow him around.
That sounds much safer.
That's right. Yeah. Let's see in a couple weeks. I'll ask.
Arinjay, how about you?
Ooh, I think Marianne surprised me. She was the student that won the survival last season. She was in the lab and she was fantastic in the lab. I never thought she'd go on. So how often do you see a scientist winning a TV show? It's crazy. But I think she was great. She had great influence. Just what would be the choice. And she brought in a lot of energy. So it's the emotions that's part of this. You guys students be very happy. You guys students very frustrated, especially with all you smart students. You all want the experiments to work the first time. It doesn't. That's a good reality check. It's science. It's not perfect. And that's all part of it. For me, just me as a personality, as a person, for me, this is building relations. When I'm 60 years old, I'm not going to look back at advancements. I'm going to look back at people I've met, the connections I've made, the TV shows that you've won. So that's what I think most of us are. Science is just
yeah, I think that's great. I don't have a bee story or anything so dramatic, but I think work closely now with a handful of students, and I think just seeing them to go out and start doing bigger things than I've ever done, I think that's like the biggest piece to me. That means a lot, and like just having those connections, and I think that's why I'm here, is to teach people to go out and make the world better. Just try, and hopefully I can help steer them a bit on the path.
Say that I had one undergrad student who was involved in screening a lot of zebrafish lines. So in our lab, we make a lot of different transgenics that have a particular fluorescent protein that is expressed in a specific cell or tissue. And we've been trying to get this going for like the last 2 years or year and a half. And when the one undergrad student was involved in screening them, he found our first founder fish, is what we call them. And it was like this big lab celebration because he was just going through the plates. And then I was just like, oh, I think this is a blue fish. And then we all went to the microscope room and it was all, we were all like, yeah, it is a blue fish. It's really a founder. So that was a big, I guess, moment in the lab, like in terms of our whole group being involved in and the excitement of somebody seeing something for the first time. So that was great.
I think that that's brilliant. And I lied. I do have one more question. Sorry. I would like to, one of the things that my office would like to work on is to just reinforce for undergraduate students that when you read the papers that get published, that tells this particular beautiful, perfect story about research. But is that actually how research works? And could you talk about that?
You know, the first question I will ask anybody that wants to do, I kid you not, this is researching that, is asking them if they're a sports. That's it starts there. I narrow down to whether or not they like certain sports. So I can use the same analogy in different versions. Because the ideal version of this is to think about like free throw shooting. Science is free throw shooting, or perhaps even 3-point shooting, right? Steph Curry misses like what, 50% of all the shots he takes. If you're like the greatest from the 3-point, right? If you're the greatest baseball player ever, you're Ted Williams, you spent about 400, so you were like successful 4 out of 10 times. Science is about redirecting your expectations to this idea where there's a number, not an exact number, but there's this expectation of this is success, and it doesn't actually mean always, it may not even mean the majority of it. If you can get your head around that, you're going to always be better off in the long term than not, because it's an exercise. That's just how it works. And you just have to be able to understand that failure actually means you try it 3 times and eventually it works, not like, you know, I tried it 3 times and 3 times. It's absolutely, I think, the most important thing you can take out of working in a lab in any context if you're going to do undergraduate research. But if you can learn that and whether or not you can tolerate it, that's going to decide whether or not you should go any further.
If the rest of you want to expand on that, the concept of failure and how you help your undergraduate students to understand it.
Yeah, I think that the other thing is the key to be self-motivated, because I think a lot of us have run into this during our research careers. It's like you've got highs and lows. You know, your experiments work fantastically, and then you're in a slump for a little while. And this is really tough because you need to be surrounded by a lab that is supportive of this. This is going to happen to you. This happens to all of us. And so thinking back to why you want to do that and what's your initial motivation is really important to help keep you sort of boosted when your experiments aren't working. And like I said, it doesn't work all the time. It doesn't work most of the time. So getting used to that idea of thinking, okay, how do I learn how to troubleshoot this? How do I apply what I've learned in some other context to maybe solve this problem? Those kind of skills are really important to have to help you through these moments.
I think for us, there are no failed experiments. Every experiment does something. I'll give you an analogy. Let's say you're driving. We do wedding, very happy. You drive over a roadkill, parking, you get a flat. You can be very upset that, dang it, this experiment didn't work. I have to get from point A to point B. I can't. Or you can teach yourself that next time I know you don't drive over a parking lot because you will get that roadkill that doesn't your flat. So I think every experiment in our lab or in any lab, I think, tell you something. It's not perhaps what you expected, but it'll tell you that, oh, you forgot to add this thing. Oh, you didn't set something up properly. You ran it for a long time, but it does tell you something. If you take that as a learning curve, not necessarily a publication, as the output of doing science, I think you'll also learn about life skills. It's made me very patient. I don't get upset with a lot of things that I did when I was your age. Because small things, right? There are bigger things that you already do. So I think it's made me very patient, feeling in the lab. and I'm more tolerant of things.
And I think you're completely right. The idea that you'll never do it again is like, that's probably the best take-home message from something that doesn't work. And that's probably what sticks with you.
My PhD advisor had this saying, that you know, if you make a mistake, but next time make it more interesting. Right? It's okay, you know, just, you know, you learn that one, so don't do that again. Find something new to make. It's kind of, you know, you're gonna do it.
That's a great point. I was also told, don't repeat the same thing, change something. If you keep repeating the same thing, there's no magic involved in science. So well, but there's no magic, tweak something. Simple, like, made a mistake, don't keep doing the same thing, try to fix it magic. Change something.
And I think just understanding all that and being okay with letting your supervisor know or whoever know that you have run into a roadblock is really important. So I think that goes back to the communication. Having open communication with whoever you're working with to help work through that situation.
There's a question on the chat. Is it common for undergrads in first or second year to participate in your research, or are you looking for upper year students?
Anybody want to take that?
One sentence. I'm trying to set up a policy to allow high school students to allow. Undergrads too late.
Really early.
But no, anytime soon.
Yep, I agree. I've got 2 students that just finished their second year that started in my lab last summer. They're still around. Doesn't matter what level you're at. Of course, it's nice if you're interested in like a 432, or well, for us it's 432, but an honors project that you can come in the summer before and get some skills there. So that would be something that's more catered or relevant for the seniors.
Yeah, and for myself in a professional college, most of the students I work with are already in pharmacy or medicine, but I certainly have other projects that undergrad not in one of those colleges could work on. So there's a spectrum of work.
And so I took that one. Are there any questions from the floor? Go ahead, shout it out.
I'm going to be different to you, but what would you say a typical day in the lab for an undergrad?
I'm just going to repeat that because my voice is a little louder. What's a typical day in the lab for an undergraduate student in your lab?
Well, I don't have a physical lab.
Great.
So for me, it depends what the student is working on. So I have one student, he's on the call, Arinjay. He's been working with me over this past summer and doing a chart review of patients that are admitted to the inpatient ward. So a lot of that work involves him reviewing charts of patients who have previously been admitted and inputting that into a spreadsheet, checking the data, coding the data. So a lot of work with Excel that way. So that's one example. Other examples of what undergrad students have done, help to create tools to help teach high school students about certain things. Yeah, it totally varies, but a lot of the work is going to be independent. We meet with each other probably once a week, sometimes more at the beginning. Yeah, I'll leave it at that.
Yeah, I'd say in our lab, it depends on what kind of project that you're on. So we have some projects where students are doing a lot of stuff with zebrafish embryos. So your day would mean that you, maybe the night before, you would set up your cross. The next day you would come in, you collect your embryos, you would sort through them. The next day you would sort for perhaps a particular transgene or one of the fluorescent markers that we have. So you get to use different kind of microscopes. We do a lot of techniques to look at gene expression, so things like T2s and immunohistochemistry. We do a lot of cloning, so that's PCR based and running gels, sort of things to make new lines. And again, it all depends on sort of what the student is looking for. So skill-wise, that's important to me that I find something that a student is able to do and interested in doing. So we've got other projects where we treat our embryos with different drugs and then image how the heart beats. So again, all of these things you pick up a different sort of skill set for. So it's hard to say what like one exact day would be like, but that would be it. And then in terms of the team, like our lab has lab meetings once a week. So 2 or 3 people present what they've been working on for the last few weeks. So everybody's involved in sort of troubleshooting their experiments and discussing how they're interpreting their data. I meet with students either once a week or once every 2 weeks, depending on their needs. And then the sort of the group themselves meets and interacts pretty regularly on a daily basis. So there's a lot of like, I love it when I go into the lab and everyone's like chattering, and it doesn't matter if it's about social stuff or their experiments or whatever, but I think it creates a really nice atmosphere where you can feel like oh, I ran this gel and it doesn't look like it's supposed to, and then people can help troubleshoot on a daily basis.
Yeah, it really. I mean, you know, for what we do, it could range depending on, depending on the project, depending on what you're sort of interested in. It could literally go from marching around a canola field with a net to flow cytometry, depending on the particulars of the particular project you're working on, and anything in between, watering plants, feeding insects, crushing insects. We have people spend all day long basically doing the equivalent of COVID testing on plants. Like it's an enormous range, and it really just depends on what specific project are. Getting stung by bees.
Any of these things, yeah. It's really what you think of it. Have lunch with the team this summers. We could go out and have lunch. Because of COVID, we haven't really been inside together. We change that. We do hang out as a group. So every once in a while, we barbecues or we do a game night. I think it's important for morale as well. Because science is so much a failure involved in science. So we really celebrate a small victories. Give them submission of the management. Let it get rejected, but we have 3 days before it gets rejected. 3 days to celebrate the culmination of the body as something like that. And there's no hierarchy for that. Your opinion is valued just as much as mine or a secret class. I discourage a hierarchy. There's hierarchy in our lab. You can come in and tell me my science sucks. That's okay. But explain to me why it sucks. Bring us some it's crappy and I just yeah.
Oh, really? I don't know the boss all the time.
So pick which lab.
Yeah. To be fair, I usually pull that out when I either don't want to do something, or when I'm quite certain that I'm right and they're wrong, which is rare, but rare instance. Which usually means I made a mistake already. Which again, I mean, I'm kidding a little bit, but that is getting back to that is also what I'm right. Part of the reason we're here isn't necessarily to tell you what to do, but it's because in all likelihood, if you're doing the stuff we did, we made that mistake before. Sometimes I'll let you make it anyway. Sometimes it's kind of like, don't do that.
Depends how expensive the mistake might be.
That's part of it. It's really how dangerous, right?
Yeah,
How dangerous that mistake is. And depending on what you're doing, some things are not safe to make. Yeah, right. And some things are like, well, whatever, it costs $50, go ahead and make a mistake.
Yeah, dangerous is a big one for us.
Yes, considering where you work. Any other questions? Please go ahead.
Oh, speaking of mistakes, is there something you wish you knew as an undergrad?
Is there something you wish you knew as an undergrad heading into a research position for the first time?
I think this is great.
Yeah.
I've never had anything like that.
Yes.
Like I didn't know that experiments didn't work every time you did.
I was very lucky. I started as an undergrad, and within like when I had experience, I worked in a mosquito lab within the first semester getting on campus. So I got caught really early on, and someone tricked me into like spending the next 20 years doing that
Research
on insects. So, but maybe I wish I knew that there was another job I could have.
I would also add that I think it's important to realize that not all labs are the same.
Yeah.
Because every lab is a different sort of environment. The
Culture,
the culture is different, and I think it's not that one's better than the other. I think it's you need to think about what you want as a student. So if you want more supervision, if you feel like I just want to get told, I need to give you this in the next 2 weeks, and you want to work independently, those are different kinds of environments that you need to find. So those are the kinds of questions that you should ask me. You're interviewing the lab just as much as the lab is interviewing you, right? You need to find a home for yourself. So thinking about, or reflecting on what you need as a scientist in training, right? Like, do you want to work with a graduate student, or would you rather have a bit more independence? Yeah, I didn't realize that everything was different. I didn't realize things were different until even now I find out that there's like some pretty big differences in how stuff are done between different labs. So talk to the students, and I think that gives you a big insight into that lab's culture.
And in fact, that point is so important. I'm going to say it twice. Before you accept to work in the lab, make sure that you get a chance to talk to the other students who have worked in that lab. I can't emphasize this enough because you have every right to say no. If your hackles are raised at any point, walk away. Yeah.
And don't forget to enjoy. The question I was reflecting on my undergrad days, PhD stuff. Look, whatever my dream was, dreamness. And hindsight, perhaps I could have taken a lot of it and enjoyed some of the times. I did love it. I enjoyed grad school and do all over again, but maybe I could have slowed down and taken it a lot more. Don't forget to enjoy, because life will only get busy. I've seen undergraduates come in, I'm so busy, I got drama in the lab, but like drama society, you know. Crazy. Take a pause, enjoy, but something fun. Just get busy.
It does. All right, more questions. Go ahead.
I have two questions.
Go ahead.
The first question is, do research or your labs run solely in the summer? No, okay. And the second question is specified towards one of the coordinators. That's okay. Ms. Katelyn?
Yeah.
When you talked about research specific to nutrition, and I just kind of wanted to see or hear what specific aspect of nutrition you would be researching.
Sure. And I guess to clarify, I work in the College of Pharmacy and
And
Nutrition that
nutrition.
are combined, but I am a pharmacist. So all of my research focuses on pharmacy. So it might be pharmacy practice oriented or campaign oriented or pediatrics and proper diet and nutrition, that sort of thing. So I myself don't have that experience, but I know there are a
Was
lot
that
of
what
people
happened?
doing that.
And you can probably find out more specifics. If you go to the College of Pharmacy and Nutrition, it's the same as our college in anatomy and pharmacology. Is that this is there with their research interests. So that might be a way to kind of figure out what everybody's doing. It might not be updated, but at least it gives you a place to start.
We were supposed to update it this year, so it might be updated.
Thank you.
Just checking on the audio. Are we back in? Can you guys hear us? It's working now. Okay, good. Thank you. Okay, next question. Yes, go ahead. So we're going to repeat the question. The question was about co-supervision, and does that ever happen?
Our lab all the time. I've got co-supervised PhD postdocs, solo supervised PhD postdocs. I can't see why we can't do it. If you come and want to bridge our lab or our labs, go for it. Come up with a new area of science, and then we'll write a big grant on it. Do it. Create your own path. That's my advice.
Beautiful. That was good. Okay. How are we doing over here? Yes, go ahead. Are there ways that students can prepare before their first day in the lab?
I mean, I think that when students have made into my lab, I give them a couple papers to read. These could be papers that come from the lab or like nice, usually it's a nice review that I think tells you a little bit about heart development, tells you a little bit about the model organism so that you're not thrown in the deep end. You're still going to feel that way though when you get in because it's all new. So don't feel like you have to study a ton of stuff before you get in there because a lot of it is practical. But I think reading a couple of these papers helps sort of set the stage for what your project's going to be. And that's kind of what I do for new people.
Who's going to moderate from back here? Questions? Yes. Go ahead.
So I guess a common misconception I had going into this was that a lot of lab work is individual, but I can see now from your answers, being part of a group becomes a prominent part of lab culture. So I guess that said, I just wanted to ask, what role does group dynamics play in your lab? Like, how does it contribute to the success of your research?
I'm going to repeat the question. How does group dynamics contribute to the success of your research?
A lot. No body is worth better than just a warm body. We don't just hire somebody that we're okay with not hiring somebody. That goes for you. If you don't feel like you're going to fit in, that's fine. Don't tell us that. And that's why in our lab, the lab decides, because in the day, you have to work with the rest of the lab, not with because I'm not going to be heading up. Although I'd like to. That's right.
You have grants to write.
That's right. So yes, our lab, part of the reason the lab decides who comes.
And I think it makes a big difference too, right? When I've seen times, not in my current lab, but in other lab environments where I've been in, where the dynamics change really suddenly because a lot of people leave or a lot of new people come in, and it does change the flow of things. And I think this is part of what a normal lab is like, because you've got people coming in and leaving all the time. So changing the dynamics are always changing. So this is why I think it's important to talk to people that are there, because they can give you a clue about how things work and how things are. Like, do the people sitting next to each other actually chat, or do everybody kind of sit there with blinders on? That kind of environment definitely changes how successful it is, because if people are willing to collaborate or troubleshoot with one another, or just sit down and go through an experiment, like what am I missing here? That's really important. I think everybody succeeds when they work together.
And I was just going to add for myself, so I don't have a physical lab space, and there's probably other faculty members who have similar type roles. It might not be part clinical and part research that mine is, but maybe they're doing something else and then they only have a small research part. So for that, I don't have tons of people working with me all the time, but there's some, and there are students who have come and gone, and always try to build connections with whomever is coming in to work on a project so that they can talk to someone else in there. So I think understanding kind of how those relationships are and what supports are available to you, if you do end up seeking out working with someone who doesn't have a physical lab space.
So like a historian, we don't have, our labs are archives. Those are our labs. And so we go to the archive and we do all kinds of things there, but and then the government pays for the archive. It's very handy. That's why we're really cheap to do research. Any questions? You guys are just full of them. Yeah, go ahead.
I guess I just wanted some clarification towards, if someone's current area of study does not fall within one of the labs you are presenting today, but is still part of their interest. For example, I've always had a hard time narrowing my hobbies or interests to one thing. I like several things. Do you think they would still be successful?
Remember I told you when I said there are several other things that are more important than skills? That's one of them. The best, so at least to me, the best possible reason you can go pick any lab that seems like it might be a good place to hang out for a while is to either decide that you absolutely detest everything that you want to do, none of it ever again. Which can happen, and it's useful, right? Or to be like, hey, this is awesome, or ideally a slice. There's like, if someone came into my lab and was like, I realize actually working on these things is terrible. I hate this. Like, well, don't get into it. Fine, no problem. Or, whatever. Or maybe they come out and be like, the virus part's cool, but the poly part's bad. Well, especially if you're only in your first or second year, maybe I call down the road and be like, hey, I know some people that are doing virus stuff that don't require any field instruments, right?
Yeah, that's
knowing what you don't like is helpful. You can't make a decision based on, I guess, so I tell all the students I advise, which is a lot, right? You can't make all your decisions based on what you don't like, but it's really helpful to know what you want. And this is exactly how you get that.
I think that the flip side of that is, and if I could maybe rephrase the question just to touch, would you accept someone who didn't necessarily train in a particular discipline? How open are you to an interdisciplinary student? Does that sound like, okay?
Like, I think people are open. So this past summer, I had a student who came from physiology. So the only reason I met her was through one of the shore events last year where we did a faculty mixer. And it was like, I don't know, she was interested in what we were doing. She had a little bit of lab experience. She was interested in maybe some of the physiology aspects of what we were doing. So it was a great match, I think. And you bring in different backgrounds, you bring in different skills, you have thought about different sort of things and doing this experiment. So yeah, by all means, if you're from a different college, there could still be ways to integrate it.
Thank you.
What we can't do is, or let's say you have archives, you want to do it in my lab, I don't have the funds to support you. But if you're a historian who'd like to test out virology for 4 months, come and try it out. That's true.
Awesome. Good question. You guys are full. Go ahead.
So yeah, I mean,
so
the department website is a starting place. Some people have their own websites of one variety or another. That's usually the place to start.
I'm just going to pause you for a second, just in case the question didn't. The question was, how do we find out what professors are working on? How do we know what's been funded, what's happening in people's labs? Sorry, Sean, go ahead.
Oh, I wouldn't even worry about it. I would just start by going through the department websites and then the faculty websites for those that have it, and then see who's doing the stuff that seems interesting. But, you know, what the funding is a limit in some cases, but it's also a thing that sometimes we can figure out. I mean, it depends. Like, I have probably half a dozen undergrads at some points in our lab because we have a lot of like tasks that people need to do. Someone's got to count, insects.
And label them properly.
So we have 150,000 insect specimens that have to be labeled, like right now. So yeah, we've got work with people from working on that.
I think you can also see things that are advertised at the university. So sometimes there's research focused articles. I know, like in the College of Medicine, they do these podcasts, and different researchers from the College of Medicine will talk about what they're doing. This might be another way to try to get to know different labs, especially for individuals who don't necessarily teach, right? Don't know who's there. It's particular. Might be another resource.
I always tell students when they ask this question, and it gets asked a lot, I always say, well, this is your first test. We need to know how well you can do research. And your first research is find a faculty member who's doing something that you're interested in, and go do some digging and figuring out who's out there doing stuff that you would like. And yeah, so that's your first test. So it's also, people also ask me, Merle, you should keep a database of what's happening. Well, there's 1,500 faculty, and they're all coming and all going, and they're all landing funding at different times, and then their funding ends, and it would be a mess, and it would be a full-time job for me just to try and keep up with who's hiring and who's not. So I don't do that. Instead, I focus on events like this to teach you guys and to give you guys the skills and the brave. I want you to be brave. I want you to be brave enough to try. And so I try and create a space so that you guys are brave enough to reach out to the faculty and go ahead and try and see if the research experience is the right thing for you.
University, you make a very good point. The university website. Like I can see my PhD supervisor is retiring next month. It's got a young photo. So I'm in a good spot perhaps to identify what broad area you're interested in. Then if you plug in that area on USA's website, you'll have some hits for some factors. Then go and stalk their publications.
Right? Like, stalk them.
Sure, stalk their publications. And that'll give you an idea of what the lab is. Then reach out to them. If that piques your interest, then email. And we'll tell you that we have no funding, perhaps next year we're expecting some funding. That's how I would do it now.
And maybe to build on that, the point that you said about funding and thinking about next year is to plan ahead, because a lot of our decisions are made in the really early. So you might think the summer is so far away, we're not even in winter yet, but we're already thinking about who's coming in for next summer because of all of the funding deadlines. So it's good to head. Even if you're interested in graduate school after, start, thinking about things a year in advance, and maybe that helps narrow down who's available.
That's actually the question that just came in on the chat. It said, when is the best time to approach faculty?
I had one today for next summer.
You hired one today for
I
next
had
summer.
one today for next summer. We had 30 applicants last week. We interviewed, shortlisted. So some people start very early. So perhaps what I hate for is erratics. Like, I think students should have access to it, but the reality is some students are going to be upset. And we also want to ensure that somebody does show up if we have funding. So for us, it's a hard balance. Do we wait? Do we take the first cohort of students that's reached out to us? I don't have an answer for it. Colleagues might.
I know I'm in the same boat now. Like, we're starting to look at CVs and start to interview candidates probably in November. And the reason for that is, so awards like the NSERC USRA or undergrad summer research awards, those deadlines are in January. And so you want to give yourself enough time to find somebody, work on your applications together. This year there's there's a student letter of motivation.
Yeah, I think
it's fantastic.
Thank you. Say that louder.
No, I think it's a great idea. You want some time to do these sorts of things.
Yeah, so that email just went out to the faculty yesterday morning from my office to tell them about the NSERC US. So NSERC is the only one of the 3 Canadian tri-agencies that actually has an award for undergraduate students. And see, the other 2, SSHRC and CIHR, don't, but we're working on them. However, so what we're asking, so that deadline is January 17th. But the thing about the NSERC is that you have to have your supervisor in place, because it's a 2-part application. You apply and the supervisor applies, and they get hooked together by NSERC. And so it's really, really important. You have to find a supervisor first, and you have to have those conversations. So you've got to start reaching out now to have those conversations if you're in the sciences and you qualify for an NSERC USRA. So yeah, that's, and we moved up the deadline by 2 weeks because we want to get those students in place and know that they have a summer job earlier, because we've been losing students because, they'll go work road construction for much more money, and which I appreciate because it's expensive to go to university. But if they have an opportunity, we'd like to get those matches done sooner. So we've made some changes with that. And so we have 4 upcoming sessions, and any of you who are in the SURE program, you'll be getting those emails that tell you about the upcoming sessions. So I've got 2 sessions that go over the NSERC USRAs and what they look like and how you apply. And then we've got a special session for students to talk about writing your statement of intent as a student, because it's a 1-pager that you have to write as a student. And we also have a session for faculty to teach faculty how to not copy and paste from their existing, and how to write a really good NSERC USRA. So just putting that in your, yeah. You guys are good.
I joined last year.
Yeah. Yes, please. It's a good question.
Oh, of course, though. Yeah, but it's nicer to be paid.
Well, no, I actually didn't even pay.
That's
I was
really-
like,
oh, yeah.
I think I started working when I was in high school through a co-op program, and then I stayed on as a volunteer. And I thought the same thing, like, well, why would I get paid? Because I'm getting something out of this as a volunteer. But now, as on the flip side, I don't think I would
No, I
necessarily do that to
understand
students.
completely. I just had no idea.
Yeah.
But
But I feel like
I'm wondering, are
should
there
get paid.
There are, yeah, there are. Go ahead.
I mean, 2 things to clarify, and I talked around it a little bit. The first thing around is there's different ways you can get into a lab as undergrad, right? So there's honors thesis type things. There's in some departments, so for instance, in bio, there's, I should know that. The 390 something or other, which is the biology independent research. That's from campus.
Oh,
There's 2
different.
things. There's an equivalent, right? That is not your capstone. That is just basically course credit and coming and do research. So that's a different opportunity, a different set of goals, and you can grade for it. Then there are things that we're going to pay you for. Sometimes it's because we're basically paying people to do jobs that we need help with. Sometimes it's because we have the funds to pay you to do research projects. There's the NSERC, and then there are some other things. So, there's tiers of this. And then, of course, you could just come in and say, I want to volunteer, which I know I'm loath to do that and have you not get something. I regret it for money. Like I want somebody to come, it makes it a more fair exchange. But, the other thing, just to plug, for those of you who are interested, especially in life sciences, the Department of Plant Science in particular hires a lot of undergrads in the summer. And you can put those applications into the office, there's an online thing. And while they do certainly prefer people who can drive tractors for a lot of those jobs, a lot of people are actually looking for people to do other things, not driving tractors, particularly the nutrition students and stuff working some of these other aspects. And they tend to get overlooked from everyone that's not an ag. And they pay really well because they pay competitive to what you get paid if you work for the ag.
With that, it's 10 after 5. And so I'm going to close this down. Thank you very much. I'm going to close this. If those of you still in the room have a question and the professor hasn't run out the door, then good luck with you. Arinjay, you can run. Thank you all very much for coming and attending, to our panelists for their time. We really appreciate it. And thank you to all of them for your great questions.